Hello there. In this video, we're going to go through section 1.4 of the KNR, the C programming language. Let's jump right in. So, section 1.4, symbolic constants. A final observation before we leave temperature conversion forever. That's sad. Forever? We never get to do linear transformations of temperatures ever again? Darn. It's a bad practice to bury magic numbers like 320 in a program. They convey little information to someone who might have read the program later, and they are hard to change in a systematic way. Yeah, like using some declared variables can help a lot. That's often how we would do it in a programming language like Python, is we would declare maybe some constants or even just parameterize what we're doing here into a function. One way to deal with magic numbers is to give them meaningful names. Sure. There is a hash define line that defines a symbolic name or symbolic constant to a particular string of characters, such as define name replacement list. Okay, let's maybe go example 1, and we'll have define, something like foo, and then I'm not sure what the rest of the syntax here is meant to mean. I guess the name and then replacement list is like, we could put, I don't know, like 10.2 is a float. We'll get into the example they have below. Let's keep going. Thereafter, any occurrence of the name that we specify here, not in quotes and not part of another name, will be replaced by the corresponding replacement text. So yeah, it's 3 pieces. There's the define, which is the same every time you want to make one of these symbolic constants. There's the name of the constant, which I assume has to have some rules about what's a valid name. And then there's the replacement list. The name has the same form as a variable name, a sequence of letters and digits that begin with a letter. Okay, that's our rule. The replacement text can be any sequence of characters. It is not limited to just numbers. So they have an example here. Let's explore it. We're going to have include. Actually, I want brackets standard io.h. And we're going to define some of these. We'll have define something called lower, and that's going to have the value of 0, and that's our lower limit of a table. We'll have define upper 300. That's our greatest Fahrenheit temperature. And then we'll have define step size of 20. That's the step size. And then we'll go back to the same familiar problem that we covered in the last video. And in fact, sure, okay, fine, I'll type it out. I was about to get lazy enough to not type out anything. So let's go integer main, just for ISO compliance here. We'll go make our for loop Fahrenheit, and here we're going to set it to be the lower bound. Fahrenheit then will be constrained in our loop. The termination condition is going to be when this fails to be true, so when Fahrenheit is greater than upper. And then our update rule is going to be Fair plus, it's a little smaller, plus our step size. And then we'll print out whatever we want to print. And let's see, let's get our percent 3D, percent 6.1f, just to show a little bit of precision in that floating number. This should be the same as what you saw basically last video, if you watched the last one. And if not, all we're doing here is we are converting from from Fahrenheit into Celsius. And that is just a simple linear relationship that we're capturing here. So there's our simple enough for loop. I always like to run this stuff, although there's no particular reason why it should say anything different or interesting interestingly different from the last time we looked at this example. Nonetheless, we'll put that as example 1, and we'll run it, and there's our output table. So, in a sense, what we've done is parameterized this loop by declaring these constant symbols that we can refer to later, and they become part of something recognized by the LSP, which is also nice if you have an LSP set up for C. All right, let's go back to the text and see what they wanted to say about this. So the quantities lower, upper, and step are symbolic constants. They're not programming variables as far as the C language specification. So they do not appear in declarations. Got it. Symbolic constant names are conventionally written in uppercase so they can be readily distinguished from lowercase variable names. Sure, I think I'm good with that. And that just helps when you're looking at that being referred to somewhere else to know that it's a constant. Notice that there is no semicolon at the end of the define line. I did notice that, and I, just out of reflex, was tempted to put them as we were writing them out, but they don't belong in C anyways, not for these special directives for symbolic constants. And that is the end of the section 1.4 on symbolic constants. So all that this talks about in summary is that there's a simple syntax for declaring constant symbols that you can use like variables, but for technical underlying reasons that are not discussed in this section, they're not the same as the usual programming variables. If I were to wager a guess, not actually knowing, I think this is back to the topic of macros, which we haven't covered in this book, but these special hash directive things give us a lot of power in our programming. Okay, that is it for this video. I'll catch you in the next one.